A solution consists of 3.2 grams of sodium chloride dissolved in 350 ml of water. What is the molarity of the solution? The molarity, being the molar concentration, is the number of moles of solute on a number of liters of the solution. So the solute here is sodium chloride, which we can convert from grams to moles by dividing through by the molar mass of sodium plus chlorine, which gives the following number of moles. Over 0.35 liters, which is 0.16 moles per liter, or molar. And here we use two significant figures as per the least number of significant figures in the problem. A 2 gram sample of calcium chloride with the following molar mass is dissolved in water to produce 350 ml of solution. Calculate the concentration of chlorine anions in the solution. Well, the molar concentration of chlorine is the number of moles of chlorine anions on the liters of the solution. Now the number of moles of calcium chloride can be obtained by dividing the mass on the molar mass of the sample. And for every mole of calcium chloride, there's 2 moles of chlorine. So when this dissociates in water, you get 2 chlorine anions per calcium cation. So therefore the number of moles of chlorine can be obtained as follows. Which gives the following result. And then dividing by the liters of solution and using the least number of significant figures in the problem, being 2, we obtain 0.1 molar. A solution consists of 3 grams of potassium permanganate, which has the following molar mass, and this is dissolved in water to form a 100 ml solution. Now 40 ml of this solution is poured in another flask and diluted with water until the volume of the new solution is 200 ml. What is the molar concentration of the new solution? Well, the molarity of the first solution is the number of moles of potassium permanganate on the liters of solution. And we can obtain a number of moles by dividing the mass on the molar mass. And dividing by the number of liters of the first solution, we can obtain the molarity of the first solution, which is in moles per liter, or molar. Now given that 40 ml was poured in the other flask, we need to obtain a number of moles in the new flask. So to do that, we can use the molarity, and that's equal to our new number of moles on the liters of solution that was poured in the other flask. And now we can obtain a molar concentration of our new solution by dividing the number of moles of potassium permanganate in the new flask by the number of liters of the new solution. And this gives 0.04 molar, where we use the least number of significant figures in the problem.